Now that we have some sort of an idea of the components inside, the main subcomponents inside the CPU, the ALU, the control unit, we are going to dig down a little deeper to get to a model of how modern CPUs work. Remember, this is a model. The reality is far more complex, but the principles are exactly the same. The first thing that you will notice is that the CPU as a whole is connected via 3 arrows to main memory. By memory, we mean a combination of level 1 cache, level 2 cache, RAM, and or the disk. So these buses would carry on through, first of all hitting the level 1 cache, and then hitting level 2 cache, then hitting RAM, and then finally hitting any secondary storage or disk. The data bus is a two-way bus. The data bus is a two-way bus, so we call this a bi-directional bus. The address bus and the control bus are both one-way direction buses, so they are known as unidirectional buses. The address bus and control bus take signals from the CPU to memory. Those signals will be made up of what address location the CPU would want to work with, and the control signal, by working with the control unit and the system clock, will control whether RAM is undergoing a read cycle or a write cycle. The data bus is the only bus that can retrieve data and instructions from memory and or actually change or write information or data back to memory. In order for the CPU to actually work, the transfer or the movement of this data from the buses into the CPU and out of the CPU can't take place in a vacuum. Instead, there are some very special, very small, dedicated memory locations inside the CPU called registers. There are different registers and each one has a different function. We'll begin by looking at the register that connects the CPU to the data bus. This register is known as the MDR, or Memory Data Register. M for memory, connects it because it's connecting to memory, D for data, and R for register. So the Memory Data Register, or MDR, stores all data coming in from memory into the CPU, and it also stores all data before it is written back to memory. Similarly, we have a register connected to the address bus. This is known as the MAR, or Memory Address Register. This register holds the address of the variable the CPU needs to access, or the address of an instruction that the CPU will need to load. We've talked about the ALU, the Arithmetic Logic Unit, as being the real technological part of the CPU. This is the powerhouse of the CPU, the part where all the calculations happen, the number crunching, because computers ultimately are number crunchers. That's what they do. So this is the part that does all the arithmetic, which includes things like addition, subtraction, multiplication, shifting, and that sort of thing. Or L, logic, Boolean operators like and or not, dealing with asking questions and seeing whether they are true or false. Connected to this ALU, you can think of this as being a really microscopic little computer inside the CPU. So just like in the big picture, the computer has inputs, processes, and outputs, the same thing occurs here. The accumulator is a special register that behaves as one of the inputs to the ALU. It is also the dedicated register that all the outputs of the ALU are sent to. You might ask, well, what other registers used as an input to the ALU? Well, it depends on the model that you're working on. It could be if you only have an MDR, then the second input would probably be stored in the MDR register, the memory data register. But modern CPUs typically have a lot of temporary or scratch registers that could be used to pull the second value in instead. However, the accumulator, the ACC register, is always one of the inputs, and it is always the output register that the results are written to. Now we come to the conductor, the orchestrator part of the CPU, the control unit. Now this is a very complex process, so there are two registers linked to the control unit. The first register is known as the PC register, which stands for the program counter, and its job is to store the address of the next instruction that will be fetched from memory and therefore executed. It stores the next instruction, the address of the next instruction. There's another register known as the IR, or the instruction register. The instruction register holds the actual instruction that is being executed at the moment. So the program counter stores an address. The instruction register actually holds the actual instruction that is being run at the moment. Now, obviously, because the program counter register stores an address, it will be hardwired to the MAR, the memory address register, so that when it needs to call for an instruction from a particular memory address, it can do that very straightforwardly. We now get to talk about the final component, the conductor, which works by, or the control unit, which works in conjunction with looking and checking the timing. So the control unit will check the system clock. In our little hypothetical model, we're going to assume that the CPU has regular tick intervals. And this is what we call a CPU tick. And we're going to assume that our instructions are going to be executed or run going through 5 instruction or CPU ticks. Each CPU tick will result in a different process happening. The control unit, by checking the clock, will then control whether memory is being written to a write cycle or memory is being read from a read cycle. So, to summarize, a quick roundup. The memory data register is connected to the data register. The MAR, or memory address register, is connected to your address bus. The ACC, or accumulator, is the input and, most importantly, the output register for calculations of the ALU. And the two important registers for getting instructions orchestrated and run and executed are connected to the control unit, and they are the PC, the program counter, which stores the address of the next instruction that's going to be executed. It is hardwired to the MAR. And finally, the IR, the instruction register, which holds the current instruction that is being run or executed. Finally, the control unit, by checking the system clock, orchestrates or controls RAM as to when a read or a write cycle is being taken place. In my next video, we have a quick run through of a hypothetical instruction cycle execution using our 5 CPU clock tick model that was described in this video. Thanks for watching. I hope you have a better understanding of what registers are inside a CPU and what their job and function is and what they are connected to.